portable LIDAR. It is based on atmospheric laser spectroscopy for remote sensing of chemical distribution in the environment of Moon. Life can be inferred by the presence of atmospheric biosignature gases produced by life that can accumulate to detectable levels in an exoplanet atmosphere. Detection will be made by remote sensing by sophisticated space telescopes. Celestial objects with exposed solid surfaces such as Mercury and T. However, a big wake-up call arrived in 1985 when a thin atmosphere containing sodium was discovered as emission lines by ground-based observations. It is natural to think that the Moon should have an atmosphere if Mercury has one. In 1988, the lunar sodium atmosphere was finally discovered, and then the potassium atmosphere. Spectrum of the Moon taken with the 65 cm solar telescope at Okayama Astrophysical Observatory in December 1996. The arrows indicate weak emission lines of the sodium atmosphere. Spectroscopy. Imaging spectroscopy, the acquisition of spectra for every point in an image, is a powerful analytical method that enables remote material detection, identification, measurement, and monitoring for scientific discovery and application research. The presence of water ice was detected through the analysis of shifts in the color of light after the crash, showing the absorption of electromagnetic wavelengths. Calculation of water-vapor mixing ratio in atmosphere. Water vapor and aerosols are two interesting atmospheric parameters that are accessible to remote measurement. The water-vapor mixing ratio, which is defined as the mass of water vapor divided by the mass of dry air in a given volume, is conserved in atmospheric processes that do not involve evaporation or condensation. Schematic of LIDAR system. The technology of LIDAR. A. DPSS laser. B. Light collecting optics. C. Detector unit. D. Data acquisition system. DPSS laser. The LIDAR uses a single microchip YAG crystal pumped by diode lasers. The laser delivers second harmonic of North Dakota, YAG, which is 532 nm in wavelength. The laser employed was Laser Export, Russian-make system. Light collecting optics. A classical Cosine crane telescope unit was employed as the light collecting optics unit. The reflecting optics diameter of telescope was 150 mm. The focal ratio was 9. Detector. A high-gain photomultiplier tube, PMT, was employed as the detector unit for converting the photons to electrical signals. Data acquisition system. Photon counter was employed in this LIDAR for generating the range-resolved photon count data from PMT signals. Algorithm flow chart. Start. Read the data from LIDAR signal. Change the raw data into ASCII data. Relationship between original data of AD and PC is analyzed and the linear region is calculated. The unit of AD data is converted into photon counting rates and is used to correct the saturated PC data according to the relationship obtained by curve fitting. At last, the gluing signal is calculated by the weighted average method. The glue coefficients, slope and intercept, determined from the regression, are used to convert the AD signal into a PC signal by using the equation C equals M at plus B single quote. Process the data for range and noise correction. Thank you.